Testing, testing, can you hear me? Testing online. Can you all hear me? I'm testing. All right, you can hear. All right, cool, you can hear me, perfect. Great, okay. All right, great. Welcome everyone to the second lecture in week 3. Yep. So before we start, I just want to quickly respond to some of the feedback that I received so far. So we have the QR code at the end of the slides, and we've got some feedback from our students. First of all, thank you so much for those who said that my lecture is great. I feel really appreciate and more motivated to work hard on the lectures. Another comment was about like the noise in the lectures. I think that was mainly about the first lecture. I think now it's pretty quiet. Cool. Other things, some of the feedback is kind of all of the course control. So one student suggested like remove the final exam. I would love to remove the final exam. That would be great. But yeah, very unfortunately, this is something out of our control. What else? Some other feedback that I think will be helpful for future terms, which is about the scheduling about the lectures. So one student suggested having the lectures and tutorials at the earlier days of the week, like Monday to Wednesday, rather than at later days of the week. Yeah, I'm actually really pushing the school to make this change, but yeah, the reason that they put our class at the later days of the week was because they prioritized like 1511 and 1521, because those are the courses that need to be taken by our students like very early in their like study. So that's why we had the later weeks of the weeks, like Tuesday and Thursday lectures. But I'm really pushing hard to have our classes earlier. Yeah, I think that's mainly the feedback. Oh, one more feedback was about the labs, like how to use the lab time better. Yeah, we are also working with the lab assistant and our tutors to make sure that the lab hours are used better. Yeah, so if you have any other feedback, let us know through filling out the form. We are actually working hard on addressing the feedback that are in our control. But like for all of control things like the exam, sorry about that. But we will do our best to support you for the final exam. We are now preparing for the exam paper. Yeah, and once the practice exam is ready, we'll let you know. So we will have a practice exam before the final, like the real exam. So you will get some practice and have an idea on like how the exam will look like. Yeah, so although we can't remove the exam, but we'll do our best to support you with the exam. Okay, cool, so let's get started. So in our last lecture on Tuesday, we briefly introduced about the static verification, especially about the tab safety. So that's like we gave a very brief introduction to that. So in today's lecture, we'll have a very quick recap, like why do we need that? And we'll also give more like examples to show how you can use that to have like a tab safe software product. Okay, cool. So do you have an idea like why do we need tab safe in our software? Like why do we need to do static verification, checking the tabs? Like why is that important? Why is that important? Any thoughts, any idea? Because we want an error message. Right, so we want to identify the bugs early. rather than like, we got no error message, we check, oh, all right, our software product is perfect, and then we release our software to the real users, and they say, why login is not working, why register not working, and they are getting nothing, like there's no message showing them what's wrong, right? That would be bad. So that's why we need to have like the tab safety, or like in general, static verification. This is the example that we showed last time. Like we had the hello and 5 at the opposite order, so that caused the tab errors. And the way that we address this can be done through like runtime, like detecting the errors through some checks using the if conditions. Right? So we can check those potential tab errors during runtime by using like console error, but returning an error. But it will be even better, like without actually running the script, like before runtime, we can actually identify those potential errors by using tab script. So tab script is like another library that we can install to our project, like how we install Jest. Very similarly, we can also install tab script on top of JavaScript. And I'll show you today why we say it's on top of JavaScript. But for now, this is an example of how tab script looks like. In overall, the structure, the logic is exactly the same as JavaScript. You can use all the functions from JavaScript. The object, the arrays, the logic, everything is exactly the same as JavaScript. The only difference is sometimes we need to declare the types of some variables. We will also show today, like some variables we need to declare as type, but some others is optional. We'll show you as well. So by adding the types to the variables before runtime, TypeScript can help us check like whether we are using those variables, whether we are calling those functions properly. Is there any potential type errors? So they will give us an error message and help us fix the bugs earlier. So the way we can install this dependency, this TypeScript dependency, is by using npm install safedev TypeScript txx. So this is how we install it. Just we are installing another dependency. So in the last lecture, I used a different one, which is instead of tsx, I used the ts node, but I'm updating txs from now. So ts node is another way to run TypeScript code, but it has a lot of problems, and we want to fix that. So this time we are using tsx, but I'll show you how to use it. Yeah, so let's have a look at our code again. So I have put all my TypeScript examples in our tester project. So it's available to everyone. So if you want to play with the code together with me during the lecture or after the lecture, it's also great. So I've already uploaded all the code there. So I pushed them there. So here they are. So the first example was mycode.ts. The way that we run it is by, I'll just copy it here, and then going back to here. All right, this is the tester project. I'll just clear. And then the way we do it is by similar like when we just installed Jest. Remember how we used the Jest? It was like node modules.bin txx, like it was Jest before, and then it's txx, and then followed by the name of your TS file. So you can have a look at here. So after you install tsx, the dependency will be installed here. So Jest was here, and tsx is here. So this is the package or the library or the framework that we use to run TypeScript code. It's called tsx. And we can hit return now. So they are returning up, oopsie, where's my code? Yep, it's returning 3 properly, right? Because like 1 plus 2 equals to 3. All right, so what if I had a tab error here? For example, instead of a number 1, I put a string 1 here. All right. In JavaScript, they will just ignore us. as we saw in the many string example. They will just ignore us. Right? But what if it's in TypeScript? What will happen? Let's have. Huh? All right. They just return as a 12. That's funny. But yeah, so that's why we are introducing another one, which is called TSC. So this is another dependency that we want to install like on top of TXS. So as you notice that although it's TypeScript, we give them a tab, but it's still not giving us the error message, right? Like how can we actually solve this tab safety problem? Now they are saying that, well, we are assigning this string to the parameter which should be of the tab number. So they are giving us the error message. All right, so you may be confused, like what is going on here? Like what's happening? So let me show you what's happening here. I'll delete this file. Right, so you can see that there's only one file now in my directory called mycode.ts. There's no other mycode.ts, right? Is that right? Can you see other mycode.ts? No, you can't, right? And then when I run like tsc mycode.ts, magic. Have a look. What's going on here? There's a new file that is created called mycode.js. So this is created, and let's have a look in here. What's happening here is they are changing our TS file into a JS file. And then they'll run this JS file. So what happening before, like when we use tsx mycode and they returned the 12, was because they changed the original TS file into a JS file, like removing it, and then run this file. So this is what's happening behind the scene. Like this is also why we say TypeScript is not a standalone programming language. It's just a package that installed on top of JavaScript. And it helps us check the type errors by using TSC. So when you are writing like TypeScript files, like for example this one, you can check potential type errors by using TSC. Yeah. So similarly, as we use JS, so this is very hard to write. Like every time we use TSC or TXA, we have no modules /bin.tsc. That's too much for us. What we can do is we can go to package.json file and add .script in this package.json file. Similarly as how we add the jest. So in the future, what you can do instead is npm run tsc mycode.ts. And then they will check the errors. So this is how TypeScript helps us with tab safety. Yep. Any questions so far? All good. So you may have like more questions like how do we actually use TypeScript? Right? Is there any other differences or what kind of tabs can we use? Let's have a look at the slides. Let's come back to our slides. Yep. So let's start with functions. So we have seen the mycode example, like how we use TypeScript in functions, is we add the tabs followed by the parameter. We use ... and then the type of the parameters. So, but we are not saying that we are returning what kind of type. This is because TypeScript is also very smart. So some of the variables, they can know directly like what type is it. So what type is that variable? So for example, when you declare variable A and you say this is hello, so do we need to declare the type of A? The answer is no. It's okay if you still declare it as a string by doing this, But this is unnecessary because when you are assigning this hello string to this A variable, it's very obvious like the type of variable A is a string. Right? But if you are not assigning a value to A when you declare it, TypeScript will require you to let them know like what is it. For example, yeah, we can't do that. So, but for these parameters, they don't know what type is it, so you need to assign a value to it. Right, so, yeah, we have already seen that. Another very useful feature about TypeScript is you can define those, you can use unions for the types. So for example, in this example, like print if ready, this ready can be a Boolean or can be a number. So when you call this print if ready function, the parameters that you use here can be either number or true or false. So you have the options here. So you can also add strings to it. So let me show you. So let's go to examples.union. Yep, here it is. So you can also add one more. So for example, you can say, sometimes I also call string here. Right, so it's also okay. So it's just any type is okay. Cool. So it means that this ready variable can be Boolean, can be number, or can be a string. So this is how we use unions as a type. Another one is, what about when we are declaring or using an array? Like, how do we define the types of the values in that array? So the way we do that is by this line, the second line here. So we are declaring this array, and then the values in this array should be number. So all the values in this array, all the values in this array should be numbers. So array, ARR here, we are declaring it as an array, and there are numbers in that. Okay, I'll show you as well. Yep. So in this array, you can see that all of the values here are numbers. However, it is also okay. So we mentioned that in JavaScript, it's different from C. Like in C, in an array, all the values should be of the same type. All the values in the array should be, for example, integers, or all of them are string. But for arrays in JavaScript, we have the flexibility. So in this array, we want to have a string, we want to have a number. It's also okay. But how can we do that when we declare that in TypeScript? We can say string or number. So that means that we are declaring this array, and in this array, it can have some string, can have some number. So we still have the flexibility. Okay. So this is one way of using array, so declaring array. So here's the example one here. So this is how we declare before, like similar as this example. So we are declaring numbers, and the value in this array are numbers, and the string or number, like flexibility here, so it can be Alice or 2. So this is one type of syntax. However, we can also use another syntax, but they are doing exactly the same thing, just different syntax. So you can also say number, and then it's an array, and what's in there is number or is string. It's just different way, different kind of syntax, but they are doing exactly the same thing. So when you see somebody write their code like that, don't be surprised. It's just another syntax, another way to declare an array with number types. Don't be surprised, but for you, just see which way you are more comfortable with, just use the way. Yeah, but when you read other people's code, you know, well, this is not wrong. It's also correct. Yeah, any question?
In the second way of declaring it, does the A have to be capital in array?
In this example, the up one.
Yeah, like when you do const names array string, does the A in array have to be capital like that?
Yeah, it needs to be capital like that. Yeah. We can also use aliases. So you may have experience using something similar in C, right? You are defining a type yourself. So now we are defining our own type. So we are not using string, we're not using number, but we are declaring our own type for TypeScript. And what it means, it just means string or number. And then in the future, for example, you are like declaring the type of item. You can say, well, its type is called list item. And what it actually means is just the type of item can be either string or number. It's the same. It's just for people to easier to read, easier to understand, fitting the specific context. Pretty straightforward. This is an interesting one. I'll show you the example in the code. It is called optional. So, so we are defining a function called substring, and we have 1, 2, 3 variables. The first 2 variables are just pretty normal. The first one is a string type. The second one is a number type. But the third one, it has a question mark at the end. It says end and then question mark. What it means is that when you are calling the substring function, you can have either 2 parameters or 3 parameters. The third parameter is optional here. So when you have a question mark followed by the parameter's name, it means that this parameter is optional. Like, how do we use that? Let's have a look at this example. So what this substring does is it extracts parts of a string. So for example, in an elephant, we want only the first 3 letters to be console logged, or like starting from letter P to the end of elephant. So we want to get a substring of a string. So this is the purpose of this substring function. And how it works, like we start with declaring a new variable called new string. And then we want to start, so with this string, we start from the number of the index, from the start index of that string. So for example, if it's 0, it means that we want to start from the first item in this string. And then if we say we only want to have 2 elements out of this string, we can include like these third parameters here. And then this modified end. Have you seen something like this, like double question mark before? No. So what this double question mark does is if the end variable, if the value of end is undefined, it's not defined, then the value of modified end will be string length, so the length of the string. If the value of end is defined rather than undefined, right, so the value of modified end will be the value of end. So that's the purpose of question mark here, the double question mark. So I put a comment here. So this double question mark makes sure that the modified end's value only falls back if end is null or undefined. So if we have the end parameters here, so like in the first example, the modified end will be just 2, so the value of end. But in the second example here, if we don't have the value of end here, the modified end's value will be string length. So this is how we use double question mark. So let's console log this example to have a look. So txx, and the example is called example optionals.tx. You can see that for the first example, it starts from the beginning of this string, which is E, and then the only need the first two letters in elephant. So which is console log here is EL. And for the second example, the end parameter is missing, so the modified end's value will be the string's length. So it means that it will start from like the second index, which is, so this is 0, 1, so this is 0, L is 1, this E is 2. It starts from here, index 2, till the end of this string, which is this one. So this is how we can use optional when we use TypeScript functions. So we can have an optional parameter. So this is very interesting. Cool. Any question about the optionals? Yeah, question.
Why the AEST print out?
Sorry?
Why the AEST print out?
Why,
The AEST print out.
why is E still print out?
Yeah.
Did you mean the first example or the second one? The second one. It starts from index 2. So index 2 of elephant, this is 0, this is 1, and this is 2. So that's why. Yeah.
Wait, so what do the two numbers represent in like elephant 0 and 2? Like, and also in the function you wrote like str string start number. What does the words before the colon mean in the function?
Which line?
5?
Line 5. What does that mean?
Yeah, like this string.
So
Like str colon.
str colon.
And
Oh, here. Str colon. What does here mean?
yeah.
Okay. So in TypeScript, for all the function parameters, we need to declare the type of the parameter. So what we are doing here is we are saying, well, this parameter, the first parameter of this substring, needs to be type string. So if we put, for example, substring and then 1 something, then we'll get an error message.
Okay. So what type of type is start?
What type is this start? Here? It's a number type. So in TypeScript, the number can be either integer or float or double. It doesn't matter. So any number is a number type in TypeScript.
Okay.
Yep. No worries. Any other question? It's okay. Any question, you can just feel free to raise your hand. All good? Okay, cool. So this is optionals. All right, so this is also an interesting one, which is about object. How can we declare the types in an object? So object is so powerful in JavaScript, right? So we use object a lot. But how can we make sure that the values in my object is of specific type? So the way we do that is by we declare a type, like declare an object type. So it's very similar like in C, you have, what was it called? You call start, right? Like you can do similar things in C. But in TypeScript, this is how we declare this object tab. So we can say, well, this is a new tab. Its name is a person. And in this person object, we have like the name key and its variable, its value must be a string. We have age, its value must be number. We have head, and its value must be a number type as well. So this is what it means. And you may notice, well, here's a question mark again after the key. So similarly as the function optionals, for tabs, when we have those question marks, it also means that when we declare, for example, we say, when we use this person object tab, age or head can be optional, but name cannot be missing. So for example, in this example, right? So person is like a tab, like object tab. And then when we say person is of person tab, and then when we add the key value pairs for person, the key value pair like name should not be missing. And the value of name must be a string because we defined it here. right? Height here is here, and then its value must be a number. But it can be optional. And we can do as what we did before, add the key value pairs later, after we declare the person variable. All good? Okay, so let's have a look at more examples here. Example, object. Yeah, cool. So here's what we have already seen from the slides. What if we want to have an array of objects? How can we do that? This is also very common. Like, for example, in the major project, you have the users, you have the data, and you may be using arrays of objects. Like, how can we adjust that to TypeScript? Right? So the way we do that is by, say, we are declaring a new variable called users, and what is this user is an array. Remember how we declared array earlier? The types of array earlier, we say constant users and then string square bracket. So you say that everything in this array should be string. So similarly, we can say the values in this array needs to be of person type. Well, this person type is this object. Does that make sense? So you have seen earlier like const, test, and what's in there, they are string, and then you have A and B. Did I have test somewhere else? Test A. Okay, cool. So this is how we declared an array earlier in TypeScript. We say the values in this array needs to be string. But now we are saying that the values in this array should be of person type. Well, this person type is actually an object. And then we can have objects in this array. And all the objects needs to follow the structure as we defined here. Does that make sense? Yeah. Similarly, we can also have an object with object value. So we can have objects in objects. So we can do similar things. So for example, we are defining another object type, which is called data. And in this data, the first key value pairs are like ID. Its value must be a number. And then the second one is user. And the type of this user must be person. And then when we actually use it, we can say we are having a new user. It's of data type with ID is 1. And then the value for user key is this one. So this is how we can have objects in array. Objects in arrays and objects in objects for TypeScript. Objects in, so this is an example of having object in an object. So the value of user is an object. Yep, make sense? All good so far? Yeah, very powerful, right? Let me double check the questions online. Rim is asking for the optional parameters. Can you assign it a default value inside the function declaration? I'm not too sure what did you mean by default value inside the function declaration. If you can clarify, that would be helpful. The question from Onazaya is, can we use TypeScript now for all our assignments and the project? like perhaps replacing all the JS files with equivalent TS files. I don't recommend doing that because the deadline is very close, and all our auto marking is based on the assumption that you are writing JS files. But you will be practicing that in the lab next week. So lab 04, you will have a chance to practice TypeScript. And in iteration 2, you are also encouraged to do that as well. But no rush, not for iteration 1. That will be too much for you. Another question from Tesla Mag. Sorry if the pronunciation is not correct. Does it create an error when you try to add a new field in an already defined object tab? Yes. It will be an error message saying that it's not defined. So for example, if you are adding, rather than adding person.age equals to 5, you say person.something equals to something. That will be an error message. Yeah, cool. I'll check the comment back later. So this is about the object. Another thing is called literals. Again, you can define your own type again. You are saying you can declare a new type called visibility, and the value of visibility should only be either private or public. It's not like a string or a number or something, just very specific. So the value of visibility can only be either private or public. So it gives you some restrictions. It's a string that you define. So let me show you how, I can't run it. So you can change that. So for example, you can say, I define another type called groups in class W17A. And then the option can be dark, like blue. So you define your own type. So it can be anything. It's just a string here. It's not just private and public. You can also define your own type here. Make sense? Yep. Cool. Yeah, so this is also an interesting one. This is a type. And this type is not number, not string, not boolean. It's called any. So what does it mean? It means that it can be any type. So for example, in this first example, function hello, and then we declare the type of name variable is any, and it's returning any type. It means that when we use hello, when we call this function, the parameter can be of any type. It can be a string, can be a number, or anything. Any means just it's any. So it's useful when you are just writing a stub function. So you are not sure what the type of that variable or that parameter should be. So you can change that later. Because sometimes, for example, in the function parameters, if you don't declare the type, you will get an error message. So TypeScript will say, I don't know what type name is. But if you put .any, they know, wow, this is just something that you come back with, or you allow any type. Yep. Makes sense? Yeah, so there's a website for TypeScript as well. Again, you do not need to memorize everything. For project or lab, you can always search online. During the exam, we'll also provide you with like similar content, so you will get all of this again, like all the documentations. So you do not need to memorize everything. Just make sure that you know where to find what. That's enough. Like in real world, like in real software engineering, you also have access to the the internet, right? You can search, look for the information in the documentation. You don't need to memorize anything. Yeah, talking about the exam, we were also consulting industry, and we asked at Alancia, like, how is their interview process? And the recruiter from Alancia said that during the interview, all the candidates needs to disable all the Gen AI tools. but they have access to, like, for example, documentations like that. So for the exam, we want to simulate a similar interview environment. So just to help you prepare for like future interviews. So we want to make sure that exam is something helpful. So although you don't have access to Gen AI tools during the exam, you will have access to those kind of documentations. Migrating to TypeScript, like how can we change your JavaScript project into TypeScript to have type safety for your project? You need to install TSC first, like to check the one that we used earlier. I'm not sure if you remember, was this one. So TSX will run the script. Well, TSC will check the text using in this file. If you got no error message, then it means that there's no error in that. But if you have an error, it will give you an error message. So we need to make sure that we install this package, like we install Jest. You need to install this one. You need to install TSX, this one. But to be able to use with Jest, we also need to install some other dependencies, like setup for the project. However, you do not need to worry about any setup or configuration. So for your lab, for your project, or even for your final exam, if any setup needs to be done, the course will do for you. So you do not need to worry about that. So the reason that we show you everything here is because if you want to have your own personal project, you want to practice yourself, you know how to set it up for your own projects. And if you saw something weird, like the file called like tsconfig.json file, you know what it is for. It is used to set up the TypeScript environment for your project. So it's just to make sure that you are not surprised when you see something like that. Okay. Cool. So similarly with npm run test or npm run jest, you can also add npm run tsc to your pipeline. So it means that when you trigger a new commit, like you pushed something to your remote repo, the pipeline will be triggered. And the pipeline will not only run your jest test, but will also test for the tabs to see whether there's any tab errors. Yeah, question? Do we need to write our own test for tab check? Yeah. TypeScript will do this for us. So the reason that we install TypeScript on top of our JavaScript is to make sure that TypeScript checked the tab errors for our project. Like we do not need to manually check ourselves. Yeah, but you will need to add this line, like npm run tsc, so that this is included in the pipeline. So when the pipeline is triggered, it not only runs the jest test, but it also tests for the potential tab errors. Yep. But you can also do it locally. So even if you don't add that to your pipeline, you can always run locally. That's what we did earlier. So what we did was here. So you can always run this script locally as well. Okay, so if you want to check all the TS files, like see if there's any tab error in any of the TS files, what you can do is by have a start here. So it will search for all the files that ends with a TS and check the tabs in all of the TS files. So let's try it. So you can see that they are running on all the TS files. Yep. All good so far. Oh, there's another question online about the exam. So how long is the exam? It's a 2-hour exam. Yeah. It's a 2-hour exam plus 10-minute reading time. So, yeah. Cool. So let's come back to the content. Again, don't stress about the environmental setup. We'll do that for you. All right, cool, amazing. So that's everything about TypeScript. Any final questions about TypeScript?
Was the question marks a part of TypeScript?
Sorry?
Are the question marks a part of TypeScript?
Is the question mark part of the tab script? Yes, so we have seen 2 question marks so far. The first one we saw was in the optional parameters for functions. So in some functions, we have optional parameters. Where's the example? Where's the example? So that's the first question mark that we saw. The second question mark we have seen is in the object. So when we declare an object, some of the key value pairs can be optional.
So when you print person, does it print all of them or does it print only name?
So person, did you mean this person or this? The first one? You can't print. You can't print this person because it's not an object, it's a tab. So it's similar as string or number. You can say, well, string and number is a tab. Can you print this tab? No, you need to print the value of a variable. So you can say this person is of person tab, and then you add value for this person. You can console log the value of this person. And when you console log it, it depends on what are the key value pairs that you declared. Yep, makes sense? Yeah, any other final questions before we move on? Yeah, question.
Can we use TypeScript to check the return type?
For function return type, like how do we declare the return type of a function? That's a very good question. So the way we do that, I'll find a function here. So you can say, I'll find an easier one here. So I want to say I want to return number. So this is how we declare the return type of a function. However, in almost all cases, you do not need to declare that because TypeScript can figure out the type of what is returned. Yeah. So you do not need to do that. But if you want to, you can add that. Any other question? Final question before we move on? All good? Yeah, so if you're interested and you want to practice TypeScript, you can use Level 4. So they are about the TypeScript. Okay, so if no other questions about TypeScript, there's another way to do static verification. So what is static verification? Do you remember? What is static verification? Static verification. So TypeScript is one way to ensure to do static verification. It checks the tab before running the script. But what is static verification? Do you remember? What is static verification? Check our code for potential bugs without running the script. Yes, that's correct. So that's what we mean by static verification. And TypeScript helps us with static verification because it doesn't require running the script. But if there's any error, you can see, for example, here, we use the npm run tsc my code, and there's a tab error, they will return, well, say, there's a tab error. And it doesn't need to be done, after we run the script. So this is TypeScript. But linting is another way to check potential errors without running the script. How does it help? It helps with the style of your code. So let me show you an example. I'll minimize that screen, and then it is here. All right, so here's a code. All right, so this is a function called loop hello. What do you think? It's so bad. Like, why is it bad? It's so hard to rate. If we can't rate this function, if we can't rate the code, it's so hard for us to identify potential bugs in there because the logic is not clear. Like it's just so hard to read, so it's hard to identify potential bugs. So what lint does is it helps us to check the style and also fix the style for us. So in 1511, like in earlier courses, you were provided with a style guide, and you manually make sure that your code follows the style guide. But now there's a tool that can help us automate this process. They can tell us, well, this line of code is it's not following the proper style. And they can even fix that for us. That'll be great, right? So let's have a look. Yeah, coding style is so important. Programs might be written for people to read and only incidentally for machine to execute. Like the first priority, we need to make sure that it's human readable so that it can identify potential issues. Why do we care about style? You have learned that from 1511. Any thoughts? Like why do we care about styles?
So it's readable.
Readable, yeah. Anything else? Anything you learned from 1511 about styles?
Easier to debug.
Easier to debug, yeah. Cool. Yeah, easier to detect by, yeah, easier to visually glance at a code with similar patterns, and consistent web space is also important. So here's an example of good and bad styles. I can see, wow, this one looks so good, right? It's just the logic, the structure is so clear. But how do we decide on the style? So you may notice that different organizations, different groups, or even different courses, they may have a different style. Like who decides on the style and how do we decide on the styles? So normally for large organizations, they have their own style guide. So for your own personal project, what you can do is you can choose the style guide that's set up by a large organization. So for example, you can Google the style guide from Google, the style guide from Facebook or Microsoft. So normally those are well established. Sometimes we may also want to modify specific style rules to satisfy our specific opinions, like priorities or ideas. In 1511, what we do is we provide you with a style guide. So you don't need to read that, you just need to know how to use it. Yeah, so this is also based on large organizations. So what we call it, the one that helps us with identify issues in our style and fix the issue in the style is called linter. So the one we call it is called linter. What it does is it enforcing style. We tend to linter the code by using software that statically analyzes your code and automatically make an adjustment. So that's what linter does. Yeah, so that's why this is also another type of static verification. It also helps us with preventing bugs without running the script. Yeah, but can linter solve the problem of bad naming of variables? No, unfortunately, linter cannot solve problem like that. So because it's mainly based on human's judgment, whether this variable makes sense, whether it is intuitive to understand what this variable is about. So it's mainly very based on humans' subjective understanding. So linter cannot help us with that, but can help with style issues or potential bugs.
What's linter?
So linter is the tool that can help us identify style errors. So for example, linters can say, this style is not good, so this line style is not good, it's not following the style guide, and why it's not following the style guide. I'll show you how to use linter, but the purpose of having a linter is to help us identify the style issues in our code. Yep, I'll show you how to use it. Yeah, okay, so the way that we again, we are using another external tool. We don't need to do everything manually. There's a lot of tools out there for us. And this one that can help us with the style issues called ESLint. This is another NPM library, an NPM package that we can use. Again, it's a very powerful tool. The way that we install it is by using npm install -ESLint. Anyone remember that why we need to have this --safe--dev when we install a package, like some of the package? Do you remember? Like we used that when we npm install Jest. Yeah. Only developers need to use it, exactly. So when we use here, safe dev, the dependency will be installed as a dev dependency. It's not like when the users use our software product, they do not depend on this library or this package. Cool. So I'll show you where is it? Where is it? Yep, here is the style guide that we provide for the course, that we use in the course. So there are a lot of rules in, like for example, no this, no this, no this, no this, no empty, no this, no that, no that. How do we actually use this style guide? By using ESLint. I'll show you how to do that. Let's go to the style, the back one, and then the way we use it is like that. We use ESLint style back, so this file, hit on return. You'll see, wow, so many errors. So the first error is missing space before opening brace. Another error is, so this is line 1. Line 2 is expected indentation of 2 spaces, but found 0. Line 2, another error, missing white space after semicolon. Line 2, and again, trailing space not allowed, and multiple problems. So by using ESLint, it will check our code style based on the style guide in this file. The file is, the file is here. So this is the style guide. It's not for us to rate. It's just for ESLint to use. So they will check our script style based on this style guide and then tell us what is wrong here. So there are some style errors. So this is another type of static verification. You can also add that to your pipeline. So whenever you push a new commit to the remote repo, it will check Jest, it will check tabs, it will also check styles. So everything can be triggered. Yeah.
How do we install this? Do we have to install it every single file that we want to use it for?
Do we need to, like, how do we install it? Do we need to install this for all the files? So it's similar as how we install Jest or how we install TypeScript. We only install it to the project. So after we run npm install followed by the package name, the package will be installed on this project. So the relevant folders will be added to the node modules. It will also be added to the package.json file. Make sense? Yeah, any other questions so far? Yeah, question.
So does the linting like format the code automatically as well, or does it just tell you the error?
A good question. So the question is, can the linter or the ESLint also fix the errors? Not just say, well, there are errors here or there. Yes, it can do. So let me show you how you can do that. It's by adding this --fix. So I'll show you. I'll copy it here. I'll put the bad style. Where's the bad style? It's here. All right, I'll open my terminal, copy and paste. Okay, look at my script. Look at my script. Do not move your eyes. Look at my script. Look at my script. Look at my script. Look at my script. All right, I'm going to hit enter now. I'm going to hit return. Fixed. Magic. Right? So you do not need to worry that much about the style or fix it manually or read the menu like the style guide and check 1 point, 2 point, 3 point, tick, tick, tick. You do not need to do that. So ESLint can do that for you. So it not only check the style errors, it also can fix that for you. Magic, right? So that's so helpful. This is a very helpful tool. Any question? So you may notice about this, yeah, question.
If we have like another formatter like Prettier installed, should we disable that?
Yes. If you have any other tools that you are using now for your style, I would suggest disable that. Just follow one style that the course provides because maybe there are conflicts. Yeah, that will be problematic. So you may notice, well, this is not perfect yet. So it's okay, like this line too is okay. But my preference is maybe like that. Maybe, I don't know. But the style guide doesn't reinforce that. It means that the current style guide doesn't say, doesn't say it's not that good. It says it's okay, it's still following the style guide. I'll run that again because it's lost. Sorry, I'll do that again. Yeah, so the current style guide is saying this is okay. It just may not look like what you prefer, but it's following the style guide. People online are asking for a break. Okay, let's have a 5 minutes break, and then we'll come back. Right, online, can you hear me? Cool, great, can you hear me? All right, before we get back to linting or ES linked, I'll just answer some questions online. Just only one question. Is there a hurdle for exam? Another exam question. Yes, there is a hurdle. So it needs to be about 40% of the exam mark after scaling. So similar as 1511, 1521. So the hurdle is like 40% and above after scaling. But the difference is for 1511, I remember that you also have a hurdle for specific questions. But in 1531, we don't do that. We believe that you are more mature, like you are not like, so, question. What was that?
You said this course has scaling, does it? Like,
You said
like 40% after scaling. Does that mean this course does get scaling? Because 1511 didn't get any scaling.
maybe. Yeah, I'm not sure yet.
It depends on the performance.
Yes, it depends. Yeah. Any other question before we get started on the content again? Okay. So you may feel like the content of the course is pretty heavy at the first couple of weeks. I feel the same, but it will slow down. I promise you, it will slow down, especially after week 4. So I will show you the course website. So we are now here. After we talk about HTTP server, the pace of the course will slow down like that. We are now kind of at the peak. You feel like, oh, it's so much going on. But it will slow down. So after the first week, in week 4, the content will be like much easier. Like much easier. So we are now at the peak. So I understand if you feel like there's so much going on, but it will slow down. Just make sure that you are up to date with the lecture content. You do the labs and you are making contributions to the project. Just hold on to it. And then after week 4, you will start to enjoy what you are doing. Cool. Another final notice before I get back to the content. Next week, so tomorrow I'll start traveling. I'm going to a software engineering conference, like learn more about software engineering and also how to do better software engineering education. So I'm traveling from tomorrow, and I will be back week 5. So while I'm away, Dr. Benjamin Tag will lecture. So next week, Dr. Ben will be the lecturer. And then I will come back in week 5. But I'm not taking many lectures after that. Ben will take most of the lecture after that. This is because we are sharing the course. So we are co-lecturing. So I mainly teach the first half, and Ben mainly teach the second half. But I will come back at the end for like the exam preparation, some more industry lectures at the end of the term. But I will come back. So yeah, you will see Ben here next week, not me. Okay, cool. Any question about ES linked? Back to our content. Oh, good. Yeah, it's very powerful, I know. There are some cases that you don't want ES link to flag the error. For example, there may have some like one-off instances. You just want to write that one like that. Like you just don't want the ES link to fix that, like following the style guide. Or you don't want ES link to flag that error. You just want it to be like that. What can you do? You can add this line. ESLink disable next line. So when ESLink check the style of your file, they will skip the next line. They will not check that. But we don't recommend you put a lot of disable lines in your code because you want your code to follow a good style. Right? But maybe there are some cases you just want to skip that. And you can do that. How you can add that to your project? Again, you can put that in your package.json file. You can add another script, say called linked, and then in the future you can do npm run linked, and then what it does, it's running the ES linked. Yeah, question?
What if you want to skip multiple lines in S-lint instead of just the next line?
What if you want to skip multiple lines in ESLint? Yeah, that's a very good question. I can't remember skip. I can't remember exactly what it is, but I'm pretty sure there are. You can ignore this whole file. You can ignore a directory. You can, yeah. So there are ways that you can ignore multiple lines or even the whole file. Again, there's the documentation for ESLint. Have a look at that, and then you can do some your like self-directed learning. Any other question? Cool, so let's get back to this. So you can go back to your package.json file, add the scripts, like how you add jest, how you add TypeScript. You can also add that script in your Python file. So in the future, you can just use npm run linked, npm run linked fix. It's just easier, make your life easier. Yeah, so again, you can add that to your pipeline. So now your pipeline will have jest test, tab check, and link check. Okay, very similar step as we did for jest and TypeScript. Any question about the pipeline or about the package.json file? All good, all good, all good. Okay, cool, amazing. ESLint, similar as TypeScript, so both are about static verification. So you can start practicing that in your labs in week 4, like lab 04, and project iteration 2. So both of these will start from week 4. Yeah, cool. So these are all about setup. You do not need to worry about that. We just put that in the slides if you want to implement that for your own project. Again, do not worry about the environmental setup. Amazing. Cool, great. So that's everything about static verification that we talk about in this course. There's HTTP servers. I love this lecture. I love this one. All right, so before we actually talk about the lecture content, have you heard of the term server? Keep your hands up if you have a brief understanding of what is a server. Just something like that. Okay. So, yeah, so what's your understanding about a server?
It's a central thing and many people connect to it.
It's a centralized thing that many people can connect to it. Yeah, cool. That's a very good way to describe that. Any other thoughts, like what's your understanding about a server? It's okay, we'll talk about that. So before we talk about what server can do, so now you are writing functions. Your functions are doing something for us, right? So for example, you have a function for login. You have a function for register. But why do you write those functions? Not only because the course asks you to do that, but imagine that you are writing a software product for real users to use. Like, how can they actually register? How can they actually log in? Like, how can they trigger those functions to perform the behaviors?
It's stored in the server.
It's stored on the server. Yeah. So the user cannot directly access the functions. So server can help us to make sure that the user can trigger the login and get a response from the software. The user can trigger the register and get a response from the server saying registration is successful, login successful, or there's an error. So it's a way for, so having a server can help the user actually use the functions. Does that make sense? So for example, you can imagine your functions. You have the admin functions, right? So all the functions are like the tools for your kitchen. So you may have a mixer, you have a microwave oven, you have an oven, you have a lot of tools in that. Right? But how can the user get the food from the restaurant, from somewhere? It needs to be a restaurant. So you need to have a restaurant first. And then the client walk into the restaurant, say, can I have a pizza, please? And the kitchen use all those functions, which is all the tools in the function to make the meal. And come back to the client and say, here's your meal, here's your pizza. Right? So you need to first have a restaurant. So the restaurant is like the server. And it listens for the client's request. So you have a restaurant, it's listening, is any customer coming? And then when a customer comes and say, can I have a pizza, please? And the kitchen use the tools, which are the functions, to cook the meal, and come back to the client and say, here's your meal. Make sense? So server is like the restaurant, and your functions are the tools in the kitchen that actually make the meal. So this is what server is. Okay, I'm not talking about this one, like the network, the internet, blah, blah, blah. So those are about 333, like 3339, another course. If you are interested in learning like how the networks work, took that course. Yeah, I'll come back to that as well. I'll come back. Okay, I'm not using this one. Okay, I'll just talk like that. Okay. Cool. All right. Have you heard about HTTP server specifically? Have you heard about HTTP server? Yep. Cool. Where did you heard about HTTP server? Like what? Like how do we use HTTP server? Everyone used HTTP server. I promise. If you used YouTube, if you used our course website, if you used Discourse forum or anything, so all of those, they are using HTTP server. So what is an HTTP server? It's a specific type of server that talks a specific type of language. It's like McDonald's. They have a different menu comparing with a restaurant like the cafe downstairs. So they have different type of menu. They talk different languages. However, different McDonald's around Sydney, they have same or very similar, almost the same menu. So they talk the same language. They have the same menu. Almost, I think that. But HTTP server, so this is like a specific type of server. They talk the specific language. Yeah, but there are other types of servers. For example, email, so they don't use HTTP server. WebSocket, so this is another type of server. Mainly for live chats. Email protocols use TCP. Video conferences, they use UDP. Etc., etc. But HTTP is mainly for web browsing. If you are using a web application like YouTube or Netflix, they all use HTTP server. So you can send a request, say, YouTube. So how do we send a request to using HTTP server? We can put one way to do that is by using a URL. So what is a URL? It's actually a request sent to the server. It's telling the server, oh, okay, I want to access YouTube. So this is my request. Please send me YouTube on my web browser. All right, So this is the request that we send them. And then I can send them more requests. I will say 1531, like show me 1531 channel. I send the request through the URL. And they are showing me COMP1531. Oh, there's another 1531. This is the old one. Anyway, so this is how we send requests to the server, and we get a response from the server. And the server is running all the time. So even if we don't send this request on YouTube, we don't send it. Does that mean that the server is not working? The server is always working. It's still working, even though we don't send a request. It's like the restaurant is open, like the McDonald's is open over there. If you don't go there and make an order, it's still open. It's always listening for the request. Right, so this is the server and the client request. And the HTTP server has their own like specific language. Like McDonald's speaks the different language as KFC. Just checking questions. All good. Is my question coming in? Cool, amazing. Let's come back to the slides. All right, so you can understand this one. So now the question is, we know what is a server. We also know like how the client interact with the server. But we also have the functions that are already written from iteration 1. What can we do? Like how can we use those functions to make our own server so that people, like the client, can trigger our functions, like register or login or create a quiz? Like how can we do that? How can we use those functions to make a restaurant? Okay. Cool. So the way we do that is by using Node.js Express Server. Again, Express Server can be installed using NPM again. We are installing a lot of things so far. So Express Server is also another like a framework that people have already built and put it on, can be installed using NPM. So you do not need to write the server from scratch. It's like for JS, you do not need to write the test logic and stuff from scratch. And for TypeScript, you do not need to manually check the text yourself. So you can install this Express Server, and then you can start building your restaurant using your functions that you have already written from iteration 1. Okay. All right, let me show you an example from, not this one, yeah. I hope you are not overwhelmed, but I will, I'll just, all right, so we need to npm install Express, like how we npm install TypeScript and Jest and ES linked. We need to install that. And after we install Express Server, we can do similar things like import Express from Express after we install. Because we have installed, we can use the functions, the things from Express. And then we can create a server by using this Express function. I will not go into too much details for now, but I will come back to it. But what I'm going to do now is just to show you how it works, and then I will explain how, like, why it works. How to run this TS code. How to run TypeScript code? Can anyone remind me? I forgot. No? How to run, like TS, this is TS. This is a TypeScript code. This is not JS, it's not Java. Like JavaScript, we just node and then follow the file name. This is how we run TS code, which is TypeScript code, is express JSON. We use npm run tsx to run TypeScript code, run it, and then I will show you how it works. It will say it's listening. Okay, our restaurant is open now. It's open, it's running, it's listening for request. Let me open the browser, and then I'll put localhost. I'll explain, don't panic. It's what's up? Not much. Okay, what's happening here? So we build a server, we start the server, like we start the restaurant, we are listening for request, and then I put in the URL as the request, we're saying, show me what's up. And then I'm receiving this response saying not much, which is what we defined here. So whenever we send the request as what's up, we get the response as not much. Your restaurant is open. It's listening for orders. And I send a request and say, show me what's up. And then show me not much. Magic, yeah, I know. I'll just play with it a little bit. Just pretty happy. Return me something different. I change the menu. And then I reopen the restaurant, open my browser. What's up? Okay, not much, just pretty happy. So I'm using the browser now. I'm not, right? So I'm actually sending the request and getting responses. So this is how it works. We only have a very, very, very brief thing here. But you can, in the future, you can have your own functions here. So you can get given a specific request, and then you can run some functions, use some of the tools in your kitchen, and then return maybe a pizza, maybe a pasta, or maybe a burger. You can define like what to respond given a specific request. Okay, so now let's come back to the code and have a look at what's going on here. So what's happening here on this line is creating a server. So you are declaring a new server called app, and it's an express server. So this is what this line does. And then what's the next one? It says const port 3001. So what is it? It's like when you say, where is the McDonald's, or which McDonald's? I'll say the McDonald's on the Anzac Parade, or I'll say the McDonald's at the East Gardens Westfield. They are different McDonald's, right? You can say the McDonald's on like anywhere. So this is saying like the port number the server will listen on. Like which server do we listen on? Actually, our slides, like the lecture slides, is also running on my local server, which is here. It's localhost 3000. So it's listening on the port number 3000. And this is the request I send, like, show me the slides, like 25 term to static verification slides. And this is what I got. Okay, let's come back to here. All right, so you may be wondering, like, what is going on here? Like, what is app.use and then express JSON? So we have seen JSON files before, so the package.json file. So we mentioned that JSON file is not a runnable script. It's different from C or JavaScript or TypeScript. You cannot run it. It's just a file to store some data. And JSON file is very popular with like software applications or at the back. It's because JSON file can be, or JSON strings can be easily changed to JavaScript strings or to C or to Python. Like it's like the language or the structure or kind of data that can sit in the middle of different kind of programming languages. So for example, I have a front end that written using JavaScript, but my backend is written using Python. Like how can they communicate with each other? JSON can sit in the middle. Right? So you may have a website like YouTube. Somehow it links you to another website, but they are using different programming language or different protocols. Like how can they communicate with each other? It's Python. So Python is very powerful in doing that. So for HTTP servers, normally the data that is transforming between the request and the response is also JSON. So we listen for the request, we change that into JSON file, into JSON data structure, and then we can process using our own JavaScript like code functions. And then when we send back the response, we also change that to JSON and then send back the request. So that's why JSON is here. So we add this middleware to automatically pass incoming JSON in request bodies by using this line. Okay, so now this is the core or the heart of this server. It's like taking the request and sending the response. How does that do that? It is like, this is the request. When we put a URL after our localhost 3001, and we say, show me WhatsApp, and then this is what is returned here. And you can also see the JSON is here. So we are also returning a JSON string. Okay, so this is what's going on here. The last part here is called app.listen on port here. And you can see it's listening on port 3001, which is console log from here. So what it actually does is we create a server, we define the server, right? And we also told them where this server is, like where this restaurant is. We also have like what is on the menu, right? What kind of food you can get here. But we need to make sure that we start this server. We need to open the door of the restaurant. We say, now we are listening for request. Tell me what kind of food you want. So this is what actually this part does. It starts the server and listen on the specific port. If you don't have this part, you define the server, you define the functions, everything, but your server is not started. It's not taking request. So this is what the last part here does. Okay, I'm checking any question online. Oh, good. Any question from here? What is the request?
Yeah, like what do we put in for it to put out something?
Yeah, so that's a very good question. There are multiple ways to send the request to the server. But for now, we only learned one way, which is by putting the request in the URL. So they listen for WhatsApp. So we
make the URL.
Yes, so we send the request through URL. So we put in the URL, we say 3001, this is the port. So we are sending the request to the specific restaurant. And the food that we want is WhatsApp. And what is returned is like what we define to be returned. So you cannot send like whatever request. So if you want to order some food that is not on the menu, you cannot get a response. The restaurant will say, sorry, we can't make this meal. It's not on our menu. So similar here, the only thing that is on our menu at the moment is WhatsApp. So only this one works. If you put something else, it won't work. I'll just put a random one. So for example, I'll say Yichao. Okay, so cannot get WhatsApp Yichao. It's not on the menu.
So do you have to, when you write the server, do you have to activate it first? Or does it already like activate?
The question is, when we write the server, do we need to activate it first? Yes, so this is what this part does. It starts the server. So we created server here. We defined what the server can do here, but without this part, it's not started. The server is not started. Any other question? All good? All right, we can move on if you have no question. Let's come back to our slides. Okay, we have already talked about that. Okay, so I'll show you another example. How to explain this? So for example, let's come back to YouTube again. Come back to our playlist. Where's 20? This is the.
Monday
Oh,
CRM
sorry,
has the
not
best
this
AI
one.
features in the game.
Especially in sales.
Uh,
So for me,
email composition.
No, this is not a good example. But what I just wanted to say is you can put in detailed request. You can put a parameter in the request. So it's like when we have functions, right? Our functions can take parameters. So we can take input through the parameters. So similarly, when we write request to the server, we can do something similar. We take parameters. So for example, in this one, with the column name is the parameters here. So it will be passed into here. And then we can use its value when we are making the meal. We take the request so we can personalize the meal based on the user's input. So maybe you are making a cake, like a birthday cake, and you want to ask the restaurant, say, can you put my friend's name on it? Say, happy birthday, Yu Chao. Can you do that? And the server say, okay, yeah, it's okay, I can do that. I can take the specific requires. So how can we do that? I will show you. I'll show you this example. So let's run this server first. If you don't run it, okay, oh, wrong server. I need to start, this is called input params. Input params. Okay, so now they are listening on port 3000. I'm running this new server, and what I'm putting the URL is after 3001 and then my URL, and then I can follow with specific parameters. So I can say COMP1531. You can see that what is returned here is this JSON string, right? So what we define here, name is COMP1531. What is .json? The reason. Sorry. What is AEST.json? Oh, so when we interact with the server, like receiving requests or sending back response, we need to pass that into a JSON string. So this is what it does. So it returns. So this is the returned, return a function. So in a function we have return, right? You write return followed by what you return. In the server we say res followed by what is returned. So what res.json means that we are returning a JSON string as this. Yeah, question. Sorry, can you repeat it? The request has that URL. Yeah. You mean REQ here? Yeah. It's not. So REQ doesn't have here, but because if we say colon followed by a variable name, this will be passed to req.params.this name. This one? No, this one's not doing anything. So you can see it's great. We are not taking specific value. We are just putting on the URL as WhatsApp.
So yeah, REQ is an empty object?
It's undefined here. Yeah. Cool, so let's try this one again, play with it a little bit. So you can say, hello, and then this is what is returned here. I'll check online for questions. Cool, okay. Yep. So this is how we can get requests through the URL. So this is called get method. So when we say app.get, we can send the request through the URL. However, not all the requests that can be sent through the URL. So for example, when we come back to the YouTube example again, let me just open the last lecture. For example, this lecture. Okay, I want to sum up, like this comment, or sum down, or heart this comment. So this is also another request that we want to send. It's not just showing me something. So when we put in the URL, we are asking the server, like, show me something. Show me this video. Show me that website. However, there are other kind of requests. We want to add a comment, like or dislike. So this kind of request is actually sent through another way. It's called post. It's like, where is post? Yeah, so this is a post. So app.post rather than app.get. So app.get is like, show me something. You are not changing the content. So show me that video. Are you changing the video? Are you editing the page? No, you are not. You are just saying, like, to the server, show me that YouTube video. Show me that page. Or next page, please. It's just like that. But sometimes, for example, if I click on that, you can see that this page is changed. Or if you click on that, or if you add a comment, add something like that, you can see that this page is changed. So this is called post. If you are changing something, you're updating something, you need to send the request through post. So if you say post, so that server knows, oh, okay, you want to change something. And then you can define, like, what exactly you want to change and how to change it. Yep. Yep. Cool. So just if you're using Mac, you can use Option plus Command plus I to look at what's happening behind the scene. Here's a method. So method is like what is just triggered. So what is the server method? Can you see that? Is that too small? Make it a little bit bigger. Yeah, so here are all the So if I click on the heart, you can see that we just triggered a post method. This is the perform comment action. You can also trigger another one. Another post method is triggered. So you can investigate what's going on YouTube website or other like web applications. So you can look into that. I'll just play with it again. Another post method is triggered. Okay, cool. Quite interesting, right? I was exploring this morning. I found it so interesting. I will just stop here today about the server. So for now, we give a very brief introduction to what server is and how to use it. Next week, Ben will talk more about how you can use your functions to build your own server and also how to test your server. So Ben will talk more about the server. Okay, that's all for today. Yeah, I'll miss you next week. I'll come back in week 5. Okay, thank you. And the broadcast.